Hello, welcome to the video notes for lesson 1-4, real numbers. The learning target for this lesson: I can determine the difference between irrational numbers and rational numbers, or an irrational number and a rational number. So, deciding whether a number is rational or irrational. In order to do that, we need to actually go backwards a little bit and understand all the different types of numbers that you've learned about in your lifetime so far that led up to rational numbers and irrational numbers. Before we do, and you'll see this graphic organizer here below that kind of illustrates what the different numbers are. All the numbers that we've talked about and that you've learned about so far fall under the category of real numbers. There is another type of number that you have not learned about and will not for probably a couple of years still. It's high school math. And those are imaginary numbers. So imaginary numbers are numbers that are not like the real numbers that we have. Imaginary numbers don't necessarily exist in the real world in situations that make sense to us. So that's a big reason why you haven't seen or dealt with imaginary numbers. But an example of an imaginary number might be, how do you deal with something like the square root of negative 36? Now, you might be saying, oh, well, the square root of 36 is 6, so the square root of negative 36 must be negative 6. But that's not true, because if you take the square root of negative 36, you can't find two numbers that multiply together to give you a negative number. Now, you might say, well, what about 6 and negative 6? But that's not squaring a number. So imaginary numbers are pretty complicated, and you need a lot more math skills to be able to handle them. So I just wanted to make you aware of them. Okay, let's talk about some of the numbers, and you'll see some of these right up here in the graphic organizer. So natural numbers. And that's the first type of number that most people learn, because they're also called counting numbers. When we first learn to count, often you will start with the number 1. Counting numbers, starting at 1, and basically these are only positive numbers. You know, when you think about children, little children who learn about numbers and counting, we don't start them off with the world, in the world of negative numbers. We start them off with positive numbers, and we usually start with 1, so those are counting numbers. Whole numbers include all natural numbers, I'm going to abbreviate numbers, plus 0. So the concept of 0, or nothing, is introduced after someone understands counting numbers. And basically, so then our counting can begin with 0, 1, 2, 3, dot, 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 because it keeps on going. Integers. Well, integers are, again, all whole numbers, so that means all natural numbers, all whole numbers. Should be capital. All whole numbers. And their opposites. Now, what I mean by opposites is opposites are negatives. So, we would start at 0 and start counting 1, 2, 3, ... Their opposites would be -1, -2, -3, and go the other way, ... So those are integers. And then, of course, there are rational numbers. And rational numbers include all of these. All integers, not whole numbers. All integers and the numbers in between integers. Now, what do we mean by the numbers in between integers? Well, up here we started with 0 and went 1, 2, 3. There are numbers in between them, like 0.5, then 1, then maybe 2, then maybe 2 1/3. So, essentially, when we talk about numbers in between, we mean fractions and decimals. Now, going the other way, because it can also be negative, so we might have -0.25 and -3/4, and then -1, and then ... Alright, so those are, now, all of these fit under a category known as real numbers. Okay, so that was all from page 21. On page 22, we're going to take a look at some different examples. Indicate all possible names for each number. Now, essentially, all of these are going to be real numbers. Whether it's rational or irrational, it's a real number. Actually, I shouldn't have done that. Well, because if there did happen to be an example of an imaginary number, then we would not have selected that. Now, from this point on, if it's, we might want to decide if it's rational or irrational. If it's irrational, it can be none of these above it. So, on the other hand, if it's natural, like 15 is a natural number, or counting number, then it will also have to be a whole number, an integer, and a rational number. It fits under all of those categories. If you go back to your previous page, remember, a natural number is inside of a whole number, is inside of an integer, and inside of a rational number. So if it's a whole number, it'll fit in integer and rational number. If it's an integer, it'll fit in that, but not necessarily going the other way. Alright? So, back to this. -1.232. Well, it's not a natural number or a whole number, or an integer, because integers, even though they include negatives, don't include the decimals. So this is just rational. Square root of 45, is that a perfect square? No, it is not. Irrational. 121 over 35. Now, that does not divide perfectly. It is not a nice decimal, but it is a decimal, so it is a rational, but not an integer, a whole number, or a natural number. Now, square root of 16 is 4. So then the negative sign goes with that, so we have -4. Not a natural number, not a whole number, but it is an integer, and it is rational. And then 21 over 3, that equals 7. And that fits all of these: natural, whole number, integer, and rational. All right? Pretty easy thing to fill out and understand. Okay, true or false? The set of natural numbers is a subset of whole numbers. Remember, the definition of whole numbers is all natural numbers plus 0. So that is true. An irrational number is a real number. Remember, all of these, rational and irrational, are real. So true. Set of whole numbers is a subset of irrational numbers. Definitely not true. Irrational numbers does not have a subset. The set of negative integers is a subset of whole numbers. Again, false. Whole numbers is a subset of integers, but not the other way around. And then a number can be both rational and irrational. That is totally false. Okay, over on page 23, a couple more quick things. Circle, actually, you know what? Yeah, we'll do a little bit of this together. I am going to ask you to do this bottom table on your own. There's only three of these to fill in. First one, though, question 1. Circle the irrational number. So an irrational number is going to be a perfect square. So, excuse me, an irrational number is going to be one that is not a perfect square. Well, 144 with the square root of 144 and the square root of 400 are rational. So all the rest, 111, 220, 160, and 200 are irrational. Circle the rational numbers. Now, here's what we're looking for. Now, technically, all of these should have a dot, dot, dot after them. So why don't you add that in, because this did not. Here's what we're looking for: a repeating pattern, like 014, 014. That means 014 are repeating. That is rational. Here we have 717, 717, 717. So the 717 is repeating, rational. 122, 11222, and then the next thing would be 111, 22222, not rational. 23, 234, 2345. I know there's a pattern there, but it is not repeating, not rational. 594, 593, 592. Again, there's a pattern, but not rational. 9693, 9693. There's the repeating decimal. This is rational. Okay, so that's it for this lesson. If you had any trouble, go back and rewatch the video. Good luck, and we will see you in math.